A flock of thousands of starlings moves at dusk like one liquid shape in the sky. It stretches into a ribbon. It folds into a sphere. Then it snaps into a wave. Each bird flies faster than 50 kilometers an hour, closer to its neighbors than one wingspan. And from the ground, you almost never see two of them collide. For most of the 20th century, nobody could explain how this was even possible. One early bird scientist studied these flocks closely enough to rule out ordinary reaction time. He seriously proposed that the birds might be reading each other's minds. It sounds absurd today, but it shows just how mysterious this looked back then. The real answer wouldn't come from a biologist at all. In 1987, a computer graphics researcher named Craig Reynolds was animating flocks for a film. He wasn't studying birds. He just wanted the flock on screen to move convincingly. So he built a program called Boids and gave each simulated bird 3 rules. Steer away from your closest neighbors so you don't crowd them. Match the average direction your neighbors are heading. And steer gently toward the center of the group so you don't get left behind. That's it. No leader, no plan. No bird told what to do. And from those 3 rules alone, real flocking behavior appeared on the screen. Reynolds' simulation was elegant, but it was still just a guess dressed up as code. Proving real birds actually follow anything like these rules took a much harder kind of science. In the mid-2000s, a research team in Rome set out to test it on real flocks. They filmed real starling flocks with banks of cameras shooting from different angles at once. Then they combined that footage to pinpoint the exact position of every bird, all at once. Thousands of birds mapped in 3 dimensions, all flying at once. And what they found broke an assumption almost everyone had quietly been making. It seemed obvious that a bird would react to everyone within some fixed distance around it. That's not what the data showed. Each starling actually tracks a fixed number of neighbors, 6 or 7, no matter how close or far. That's the key difference, watching a number, not a distance. And that difference matters, more than it sounds like it should. If a falcon dives in, and the flock squeezes tight, a distance-based rule falls apart. A rule built to watch 6 or 7 birds holds up exactly when it matters most. Most people watching a flock overhead never guess there's an actual number behind it. This is what we do here, find the real rule, hiding inside an everyday sight. If this one earned it, hit like. Subscribe, and there'll be another one waiting. Watching 6 specific neighbors sounds simple. Doing it in under 1/100th of a second is not. Birds process visual motion far faster than humans do. Many fast flyers can register a neighbor shifting position in less than 1/100th of a second. Their eyes sit on the sides of their head, giving them almost a full circle of vision. They can watch birds ahead, beside, and behind them without ever turning their head. Their brains are small, but they pack in brain cells at a density that rivals many mammals. A processor barely the size of a walnut, built for split-second decisions. Even with all that speed, there's still something no amount of fast reacting alone explains. When a hawk strikes one edge of a flock, birds hundreds of meters away often turn almost instantly. That's too fast to be one bird, simply reacting to the next, one at a time. The turn spreads through the flock, like a ripple through water. It moves faster than any single starling could ever fly, up to 40 meters a second. They describe the flock as finely balanced, right on the edge between order and chaos. One bird's move can sweep through the entire group almost instantly, no matter how big the flock is. So somewhere in that crowd, one simple rule is doing all of the work. But no single bird needs to know that rule exists. No starling knows what the murmuration looks like. None of them is trying to draw a wave, a ribbon, a sphere. Each one is just watching 6 or 7 neighbors and adjusting. Nobody's in charge, and the flock still moves as one. There's still a simpler backup rule. For the moment 2 birds are headed straight at each other. Researchers tested this directly, releasing pairs of budgerigars on a deliberate head-on collision course. Birds facing an imminent crash overwhelmingly turned right. Nobody taught them that. It's simply what they do. And birds inside a flock aren't holding fixed spots either. They're constantly swapping places with their neighbors through small changes in speed. Predators are the likely reason all of this evolved in the first place. A tight, constantly shifting crowd of nearly identical birds is genuinely hard for a hawk to lock onto. Every sudden shift makes it harder to pick out and chase one single target. More birds also mean more eyes watching for danger, and the alarm spreads almost instantly. And every bird has a personal reason to stay near the center of the group. The outer edge of a flock is the most dangerous place to be. Flying this closely, this fast, without colliding, that isn't a separate skill layered on top. It's the reason a flock this dense can exist at all. Different flocks are solving different problems, though. Geese and ibises flying in their familiar V shape are after something elsey, saving energy. A bird flying behind and to the side can ride the swirl of air off another bird's wingtip, much like a cyclist tucking in behind another rider. Tracking data from flying ibises shows this measurably lowers their heart rate over a long flight. The dense, cloud-like flocks in this video are built for a different kind of advantage. Staying alive, not saving fuel. And the local rule idea behind all of this has escaped biology completely. Swarm robotics. Researchers use the same principle to keep drone fleets flying safely together, even if a shared radio signal gets jammed. Self-driving car engineers borrow the same idea. An onboard computer only tracks a handful of nearby cars, not every car on the road. Reynolds built Boids for a movie in 1987. It still runs inside films and video games today. A trick built for entertainment ended up teaching biology something true. Some things are still genuinely unknown. Nobody has fully mapped out how a bird's brain tracks several specific neighbors at these speeds. And it isn't clear whether every flocking bird follows this same 6 or 7 rule, or whether fish schools and insect swarms are running on rules of their own. Nothing overhead was ever following orders. There was never a plan, never a leader, never one bird holding the picture in its head. Next time you see a flock bend through the sky like one living thing, look closer. It's thousands of small decisions, made all at once, by birds close enough to see each other. Nothing more. That's a strange kind of trust to witness. See you in the next one.